Welcome back to the next tutorial class. So, we are doing the problems on the pointing vector. So, next problem is given h is equal to ux sin by in a source free region, determine E and E. So, first is the complex and second one is instantaneous electric field. So, determine E and E. So, h is given, h is equal to ux sin by. So, we have to find out this. So, given is, so this is the fourth problem, given is h, given h equal to ux sin by, vector h is equal to ux sin by in a source free medium. So, instantaneous quantity for this we can find out like this, h is equal to root 2 real part of, so instantaneous quantity for this magnetic field h e to the power j omega t. So, h will be ux sin by, so we can substitute there, root 2 real part of ux sin by e to the power j omega t. So, e to the power j omega t can be written as root 2 ux sin by in the bracket cos omega t plus j sin omega t. So, real part will be a square root 2 ux sin by cos omega t and j sin omega t will not take. So, this real part will be root 2 ux sin by cos omega t, cos omega t. So, this is the instantaneous forms of magnetic field, and from the Maxwell equation we can write so del cross h we know means del cross means we can do in the instantaneous, del cross h equal to del d by del t plus j. So, because here it is source free, in the problem it is written it is source free region. So, j will be equal to 0 and d we can write epsilon into E. So, E will be here in the instantaneous form. So, we can write this del cross h. So, this can be written as del y del t and d will be epsilon E plus 0. Because epsilon is constant, it will come outside, and E we can write instantaneous forms of E we can write 1 by epsilon naught epsilon r. It can be written, epsilon can be written as epsilon naught into epsilon r integration on 0 to t del cross h into dt. So, it can, because differentiation on this E, it can be taken this side and it will be integration. So, now we have to find out the del cross h. So, del cross h will be del we can write del y del x ux plus del y u by plus del y del z uz, and it will be cross with h. So, h we have already calculated, that is root 2 ux sin by cos omega t. So, this is the H. So, we can do the cross product. So, u x cross u x it will be 0, u y cross u x. So, it will be minus u z, but there is by component. So, it will be for the first term it will be 0, because u x dot with u x cross with u x will be 0, and u y cross u x it will be minus u z. So, it will come minus u z, and differentiation with respect to del y on sin y. So, it will be cos y cos omega t into root 2. In the next part, u z cross u x it will give u y, but there is no z component in the h. So, this term will be 0. So, third term will also 0. So, final value for E will be means del cross h. This is del cross h. So, this first we have calculated del cross of h. So, del cross h equal to minus root 2 cos by cos omega t u z. So, this is the del cross h. Now, we can substitute there, means in this electric field expression, and this is the integration with dt. So, cos omega t that will be sin omega t and divided with omega. So, E will be minus root 2 cos by sin omega t divided with epsilon naught epsilon r omega, because integration on cos omega t that will be sin omega t by omega, and here field will be in the z direction. So, this is the instantaneous form. So, we know means E is like 1 root 2 real part of e to the power j omega t. If we will take the E component like this, now we have to compare and we have to find out. We know the left side. Now, we have to find out this component. For this component, if we will take j cos by divided with epsilon naught epsilon r omega, then it will satisfy the real component of this will be this. So, and u z. So, this has the u z. So, in the determine E and E. So, we have calculated the E and E. So, we can go to the next problem. Next problem is, so that instantaneous Poynting vector is given by vector r, that is the instantaneous Poynting vector, equal to real part of s plus E cross h into e to the power j omega t. So, this have to prove instantaneous Poynting vector equal to real part of s is the complex Poynting vector, plus E cross h e to the power j to omega t. So, here we have to derive. So, this is the fifth problem, right? Yeah. So, for the fifth problem, here it is r equal to, this is the instantaneous Poynting vector, r equal to real part of s plus E cross h e to the power j to omega t. So, this have to prove. So, this will equal to this. So, first we can write the means standard equation. So, for instantaneous electric field we can write a square root of real part of E. So, this is the instantaneous part and this is the complex part, e to the power j omega t. Similarly, for the magnetic field we can write a square root of real part of h e to the power j omega t. So, r can be written as r equal to E cross H. Instantaneous Pointing vector can be defined as E cross H. So, both E and H is in the instantaneous form. So, here we can write, so root 2 into root 2, it will be 2 real part of e to the power j omega t into real part of h e to the power j omega t. So, this can be written like this. Now, because E vector is this part, complex part. So, this is a complex. So, we can define means E as E1, we can separate real and imaginary part, E1 plus j E2. So, this is also vector and H we can write H1 plus j H2 and we can substitute in the above equation. So, this will be, so first we can find out, so real part of this will be real part of E1 plus j E2 and e to the power j omega t will be cos of omega t plus j sin omega t, and real part for this will be, so here will be E1 cos omega t, E1 cos omega t plus j square equal to minus 1 minus E2 sin omega t. So, this will be the real part of e to the power j omega t. In the next part we can similarly we can find out h e to the power j omega t. So, in the same way we can write real part of H1 plus JH2 into cos omega t plus j sin omega t. So, this will be H1 cos omega t minus H2 sin omega t. So, this is the real part of h e to the power j omega t. Now, the complex Pointing vector that we can write r equal to vector r equal to, that is 2 real part 2 into this and this, real part of e to the power j omega t, real part of h e to the power j omega t. So, we can write these two equation r equal to 2 E1 cos omega t minus E2 sin omega t, this into H1 cos omega t minus H2 sin omega t. So, after multiplication we can write like this 2 into E1 H1 E1 H1 cos square omega t this, and then minus E2 minus E2 H1 this into this, minus E2 H1 sin omega t into cos omega t, this into this and this into this, minus E1 H2 sin omega t into cos omega t, and in the last part plus E2 H2 sin square omega t. So, this will come, and after multiplication with 2 it will be 2 E1 H1 cos square omega t. 2 cos square omega t will be 1 plus cos 2 omega t. So, it will be E1 H1 2 cos square omega t 1 plus cos of 2 omega t, and 2 sin omega t into cos omega t, it will be sin 2 omega t. So, this will be, so this is only for this, minus E2 H1 minus E2 H1 sin 2 omega t, sin 2 omega t minus E1 H2 sin 2 omega t plus, for this term 2 sin square omega t 1 minus cos 2 omega t E2 H2 1 minus cos 2 omega t. So, this will come, and after this we can further simplify as E1 H1 plus E2 H2 this term plus E2 H2, and we can take cos means cos 2 omega t and sin 2 omega t common. So, if we will take cos 2 omega t common, so this will be plus cos 2 omega t we can take common 2 omega t. So, this will be E1 H1 this term E1 H1 minus E2 H2 minus E2 H2. So, this cos 2 omega t, and similarly we can take the common minus sin 2 omega t. So, minus sin 2 omega t, it will be E2 H1 this term E2 H1 plus E1 H2 plus E1 H2. So, this will be the instantaneous Poynting vector, and we can go now to the right side. So, S will be E cross H a star. Complex Poynting vector, S is the complex Poynting vector. So, we can go to the right side. So, it will be E cross H star. So, that is the complex conjugate, this is the complex Poynting vector. So, this will be we can write E1 plus JE2 cross with, this is cross product H1 minus JH2, H1 minus JH2. So, this will give E1 H1 E1 H1 and real part we can write first minus J square plus E2H2 plus E2H2 plus E2H2 plus J E2H1 and minus J E1H2. So, that we can write plus J E2H1 J E2H1 minus this and this E1 H2. Like this we can write the E cross H star, and next part is E cross H. We can do this also in the separate, and then we will substitute all the value. So, E cross H will be E is E1 plus J2 cross with H1 plus JH2. So, this will be E1 H1 and J square equal to minus 1. So, real part that will be minus of E2J2 minus of E2H2 plus J we can take common, and it will be E2H1 plus this E1H2 plus E1H2. So, this will be the E cross H star. Now, we can substitute all this value, and also we can do this term E cross H into e to the power j 2 omega t. This part we can do E cross H into e to the power 2 j 2 omega t. So, this will be so this multiplication means total term this term into cos 2 omega t plus j sin 2 omega t. So, that we can write. So, this will be E1 H1 minus E2 E2H2 plus, so this is the real part, plus J E2 H1 plus E1 H2. So, this is the imaginary part, and this is multiplied with e to the power j 2 omega t. That means cos of 2 omega t plus j sin 2 omega t. Now, we have to extract the real part. So, from this we can multiply. So, real part will be cos 2 omega t, means in this case after multiplication we will get E1 H1 minus E2 H2 into cos 2 omega t, and in the another real term will be j square minus 1 and minus of E2 H1 plus E1 H2 plus E1 H2 into sin 2 omega t. So, these are the real term and imaginary term will be plus j sin j sin 2 omega t, and this term this and this E1 H1 minus E2 H2 minus E2 H2 this, and next imaginary term will be j cos of 2 omega t E2 H1 plus E1 H2. So, these are the final expression. After this we have to find out the real part of S plus E cross H into e to the power j omega t. For that we have to find out the real part of S plus E cross into e to the power j 2 omega t. So, real part of S we can see, we have already calculated that S is E cross H star. So, E cross H star, and it has this term, means this and this. So, this is the only real part and second term is the imaginary part. So, only this term will come, E1 H1 plus E2 H2. So, real part we can write directly E1 H1 plus E2 H2. So, this is the real part for the S first part, and for the second part E cross H e to the power j 2 omega t. For the second part, real part is this term, real part is this term, right. So, this will be the real part for the second part E cross H. So, for that we can write so, that will be E1 H1 minus E2 H2 cos of 2 omega t and minus E2 H1 plus E1 H2 into sin 2 omega t. So, this is the total expression for the right hand side, and in the first part we have obtained that so E1 H1. So, we can see this is the instantaneous Poynting vector, and there we obtained this one. We have obtained this part E1 H1 plus E2 H2, and here we have also obtained E1 H1 plus E2 H2 plus E1 H1 minus E2 H2 plus E1 H1 minus E2 H2 into cos 2 omega t. So, here also E1 H1 minus E2 into cos 2 omega t, and in the last part minus sin 2 omega t E2 H1 plus E1 H2. So, my E2 H1 plus E1 H2. So, E2 H1 plus E1 H2 into sin 2 omega t, and that is with minus sign. So, like this we can derive this given expression, this one. So, this is the solution for this. Next we will do this. So, consider the unit cube shown in below figure, which has all sides except the face x is equal to 0 covered by perfect conductor. So, this is the metal unit cube and its face is all side it is covered, but at x is equal to 0 it is open, x is equal to 0 it is open. So, this face x is equal to 0 that will be open. If E z is equal to 100 sin pi by and h by is equal to e to the power j pi by 6 sin pi by, over the open face it is kept, some E z and h y is kept at the face, means at the interface x is equal to 0 and no source exists within the cube. There are no source inside the cube. Determine the time average power dissipated within the cube. That is the first part, time average power dissipated within the cube, and next is the difference between time average electric and magnetic energies within the cube. So, let us do this. So, this is at so at x is equal to 0 it is open. So, x is equal to, that is means we can write for x is equal to 0, for x is equal to 0 we can write the ds vector as, at x is equal to 0 means it is open face. So, that means d by dz into ux, we can write dx like this, right. So, like you can see x is equal to 0 in the, that means it is by z plane. So, power, total power in from the interface we can write this like, means this like E cross h star into ds. So, E cross h star, so h star that will conjugate of that. So, E we know, means it will be, because this is the all side are unit cube. So, it will be 0 to 1, y is equal to 0 to 1, z is equal to 0 to 1, 100 sin pi by into e to the power minus j pi by 6 into sin pi by into dy into dz. After this we can do the integration, means 100 will come outside, e to the power minus j pi by 6 will come outside, and 0 to 1 this sin square pi by. So, 0 to 1 sin square. So, this will give 1 by 2, this will give 1 by 2, and that dz integration will be 1. So, 50. So, this value is 1 by 2, 50 e to the power minus j pi by 6. So, we can extract this cos pi by 6, 50 into cos of pi by 6 minus j sin pi by 6. So, 50 cos pi by 6 root 3 by 2. So, it will be root 3 by 2. We can write one more, root 3 by 2 minus j 1 by 2. It will be 25 root 3 minus j 25. So, this is the power input. So, it from this we can write, so first is power, time average power dissipated within the cube. So, power dissipated will be the real part, that is 25 root 3, and B part is the difference between time average electric and magnetic energy within the cube. So, that will be 2 omega Wm minus We, that will be minus 25. So, this is answer for the A part, and this is the answer for the B part. So, like this we can solve this problem. Thank you.